This is topic 1.8 of AP Pre-Calculus on rational functions and zeros. If you find this video helpful, share, like, and subscribe. Recall, a rational function is a function that is a ratio of two polynomial functions. Okay, example of this polynomial function is this like 2x over 3 divided by x squared minus 4x minus 45. So if you're going to look at it closely, the numerator and the denominator are actually made up of polynomials. Two important traits of a rational function. Let f of x equal g of x divided by h of x. So let's look at the g of x and h of s respectively. They are actually the numerator and the denominator. So in here, what it's saying is that let's assume that both of these have no common factors. Okay, no common factors. So the f of x has zeros when g of x is equal to 0. So in short, in the numerator, you are going to actually find the zeros of the rational function once it's going to be equated to zeros. And f of x is undefined when h of x is equal to 0. The denominator is now going to tell you the undefined values of x. Okay, they are not actually part of your domain. Take note in here, when solving the rational inequalities, we need to identify both the zeros and the undefined values. Okay, just to give you a short reminder, the zeros are actually found in the numerator and the undefined values are actually found in the denominator. Okay, so here are some solving rational inequalities tips and steps, if I can say. So number one, make sure that inequality has 0 on the other side. Make sure f of x is equal g of x over h of x. Make sure that you have a single rational function. Number three, set g of x is equal to 0 and h of x is 0 to find the values to include on the sign chart. Okay, if needed, we have to also factor both denominator and numerator to make it more simpler to solve. We can also create a sign chart with all values from step 3. Number 5, be careful to mark the values for h of x so that we never include those values in our solution. So h of x, remember that h of x is your denominator, and I said earlier, the undefined values is actually found in your denominator. Okay, we're going to also test in each interval to see if the values in the interval are negative or positive. Okay, interpret the sign chart to answer the given inequality problems. So we're going to be dealing with inequality problems in here. Therefore, I hope you're going to remember all of these things. Lastly, but not here, be sure to write your answer in interval notation and to think about the endpoints. Okay, so in the interval notation, we are actually using parentheses. We also use brackets. Okay, so I would like you to be very, very aware how to use these symbols, okay? Okay, so let's look at number one. The first thing we're going to see here is let's find the zeros. Okay, what are the zeros in here? The zeros is located, if I'm going to equate this to 0, that's going to give me equals 2. And the undefined values are actually located at, we'll equate this, the denominator equate it to 0, and that's going to give me x is not equal to negative 6 and 3. Okay, these are the numbers that's going to make the denominator 0. Next, we're going to create our number line. Okay, we have our critical points in here. We have negative 6 down here. Then you have 2 and then 3. So this is going to be, from this point, this is going to be your negative infinity to negative 6. We're going to get one value in there. Let's say f of negative 10. And we're going to substitute it into the rational function. So here, negative 10, negative 2, it's going to give me a negative sign, right? And then negative 10 plus 6 is still going to give me a negative sign. Negative 10, negative 3 is still going to give me a negative sign. So there are three negatives in here. It means my result in here is going to be negative. So on this interval, negative infinity to negative 6, the sign is negative. So for the interval negative 6 and 2, I'm going to get 0 and put it in the equation. So 0 minus 2 is going to give me a negative sign. New denominator, 0 plus 6, it's positive, and 0 minus 3 is going to give me a negative. So this is going to give you negative, negative is positive, multiplied by a positive, it's going to be a positive. So in this interval, the sign is positive. For the interval of 2 and 3, the only number I can get in here is actually 2.5. So f of 2.5, that's going to be 2.5 minus 2. Still, it's a positive on top. Denominator, 2.5 plus 6 is still going to give me a positive. 2.5 minus 3, that's going to give me a negative. So in here, the sign will be negative. So for this interval, 2, 3, the sign is negative. For this interval, 3 to positive infinity, maybe I'm going to get 10, f of 10. Okay, so that's going to be 10 minus 2. It's going to give me a positive on top. Okay, then the 10 plus 6 is still positive. And then 10 minus 3 is still positive. Conclusion, I have positive in here. So for this interval, it's positive. So to answer the question in here, solve for the rational function where it's going to be greater or equal to 0. So in here, we can see that these are the positive parts. This is where you can see the greater or equal to 0. Therefore, our answer in here is going to be from negative 6 to, so we're going to use a bracket in here because 2 is actually a 0. Okay, here this is a 0. This is going to be undefined, so they are not part of our solution. And then that's going to be the union of 3 to infinity. Okay, so from here and then here, so it's going to be a union. Or we can also say, we can write it this way also. We put negative 6, that's going to be less than or lesser equal to 2, and x is greater than 3. Okay, so let's look at example number 2 in here. So this is very nice because the first thing I notice in here is that I have to factor the numerator and the denominator. Here, this is going to be x plus 2, and then x minus 2. Down below, it's going to just be, this is 25, so x minus 5 square, or x minus 5 times x minus 5. Okay, so let's find the zeros. The zeros are located where? Okay, it's going to be located at negative 2 and 2, while the undefined values are actually located at x not equal to 5. So let's build our line number. So I have my negative 2 in here, and then 2, and then in here is going to be 5. Let's not forget there's also an infinity in here, and there's going to be a negative infinity in here. For this interval, negative infinity to negative 2, maybe I'm going to get again negative 10. Okay, and let's see what are the signs that's coming up. So in here, negative 10 plus 2, that's gonna give me a negative sign. Okay, x negative 10, negative 2 is still a negative. Denominator, it's going to be negative 10 minus 5, still a negative, and also with the other factors. So if you're going to simplify all of this is going to give you a positive. So for this interval, you have a positive. So for this interval, I'm going to get 0. Okay, f of 0. So 0 plus 2 is going to give me a positive here, and 0 minus 2 is a negative. Denominator, 0 minus 5, they are both negative. So this is going to give me a negative, right? Okay, so that's gonna be a negative. So for this interval, negative 2, 2, it's going to be a negative. For the interval of 2 and 5, maybe I'm going to get 3. Okay, so here f of 3, So 3 plus 2, it's gonna give me a positive sign. 3 minus 2 is still a positive sign. Here, 3 minus 5 is going to give me negative, and also with this the other factor. So positive times positive is positive, negative times negative, so a total of positive in here. So on this side, I have a positive sign. Let's go to the last interval. That's going to be from 5 to infinity. Maybe I'm going to get 10 again. That's the easiest one. So 10 plus 2 on the numerator is going to give me a positive sign. And then 10 minus 2 is still a positive sign. Denominator, 10 minus 5 is still positive, and the other is also positive. Therefore, this is going to give me a positive. So the last interval is also a positive. In here is that solve for the rational function where it's going to be less than 0. Here, less than 0. So if it's less than 0, we can only find it from here. Also, we know that negative 2 is actually part of the domain, except for 5. That's going to have an open circle. The final answer here now is going to be, the rational function will be less than 0 from the interval of negative 2 and 2. Or we can also write it this way, the x value less than negative 2 and 2. Okay, so this is the answer to this exercise. Let's look at example number 3. So in here, we cannot see any zeros from the numerator. So zeros, none. What about the undefined parts? The undefined parts is actually located at x not equal to 3. Okay, so let's build our number line. Here, this is going to be 3 only. Okay, it's going to be an open circle because 3 is not part of our solution. So let's get a number from the left side of 3. Okay, let's say this is coming from negative infinity and this is positive infinity. So let's say f of negative 10. Of course, on top of this is going to be a positive. That's going to be negative 10. Negative 3 is going to give you a negative. So the result is going to be negative. On this side, I'm going to get 10 again, okay? 10. So this is going to be positive, and 10 minus 3 is going to give me a positive, therefore it's going to be positive. So to answer the problem in here, that is rational function greater than 0, so we can see that greater than 0 in here is only on this part. Okay, so to answer that, we can say that it's going to be from 3, the interval of 3 to infinity. Or we can also write it as x should be greater than 3. So these can be the two possible answers in this specific example. Okay, so let's look at example number 4. So in here, I can see that in this example, I need to factor my numerator. 4 times x plus 2. And down is just going to be x plus 5. Let's find the zeros. The zeros, there's only one zero in here. X is equal to negative 2, and the undefined part is going to be x not equal to negative 5. Okay, let's create our number line. Here, we only have negative 2 and negative 5, but let's start first with negative 5 in here. And this is negative 2. Now, negative 5 is not part of the solution, and this is going to be a closed circle. So from this interval, let's choose a number. I'm going to choose negative 10 again. It's the easiest number I can think of. So that's going to give me negative 10 plus 2. It's going to give me negative. And then down, it's going to give me negative 10 plus 5. It's going to give me a negative also. So divide both, it's going to give you positive. So for this interval, negative infinity to negative 5, the sign is positive. Okay, for this interval, negative 5, negative 2, I'm going to choose negative 3. Okay, negative 3 plus 2 is going to give me a negative on top. Negative 3 plus 5 is going to give me positive. So this is going to be a negative. So for this interval, for negative 5, negative 2, the sign is going to be negative. So from the interval of negative 2 to infinity, we're going to get 10 again. F of 10. So 10 plus 2 is going to give me a positive on top, and 10 plus 5 is going to give me a positive below. So that's going to give me positive also. Now what is asked in here, it should be less than or equal to 0. Okay, so let's see. That part is only seen from here on this interval, on the negative part. So since this is open, we're going to use parenthesis negative 5 and negative 2. And since this is closed circle, we use bracket, the closed one. Or we can also write it this way. Okay, that's going to be negative 5 less than x, and then that's equal to negative 2. Okay, so this is your answer for this exercise. Let's go for the next one. Example number 5. Here, let's first look at the zeros, okay? Here, the zeros are located at x equal to 1 and negative 2 with a multiplicity of 2. Now, the undefined parts is located at x not equal to 2. Okay, so let's create our number line. So we have negative 2 down here, and then I'm gonna put 1 here, and then 2 in here. So negative 2 is a closed circle and also with 1. Okay, and 2 is going to be open. It's not part of the solution set. So from negative infinity to 2, I'm going to choose 10 again. Okay, negative 10 I mean. So in this case, that's going to give you negative 10, negative 1 is going to give me a negative. Okay, and then here negative 10 plus 2 is going to give you negative, but since it is squared, it's going to become positive. Okay, negative 10, negative 2 is going to give me negative, so this is going to give me a final sign of positive. So in this interval, it's positive. Now for the interval of negative 2 and 1, I'm going to choose 0. Okay, so 0. So in this case, 0 minus 1 is going to give me a negative. Then 0 plus 2, it's gonna give me positive. Down is 0 minus 2, it's a negative again. So this is going to give me a positive result. So here, this is positive. So from the interval of 1 and 2, I'm going to only choose 1.5. That's the only choice we've got in there. So let's say 1.5 minus 1 is still going to give me positive, okay? And then 1.5 plus 2, okay, it's still going to be positive. Then 1.5 minus 2, it's gonna give me a negative. Therefore, this is going to be a negative. So on this interval, it's negative sign. So finally, this is going to be 2 to infinity, okay? Positive infinity, so I'm going to choose 10 again in there. Value is 10. 10 minus 1 is going to give me a positive. And then 10 plus 2 is still positive. Then 10 minus 2 is still positive. So this is going to give you all positive. So for this interval, it's all positive. So they are asking us, that's going to be greater than 0. So greater than 0 is on this positive part. And then this one. So we can write it this way. It's going to be from the interval of negative infinity to 1. Okay, 1 is here from here. That is a 0. So we're going to use a bracket in here. And the union of 2 to infinity. Or we can also write it this way. X is lesser equal to 1. and here, and x should be greater than 2. Okay, so this is the answer to your exercise in this specific example. Okay, so let's look at example number 6. So in here, we can see again that there are no zeros. Okay, zeros, it's actually NA, not applicable. The undefined parts is going to be x is not equal to 1. So with that said, we're going to create our number line, and there's only 1 in there. Okay, that's only 1. Okay, so let's choose from negative infinity to 1, this interval. We're going to choose, let's say, negative 10 again. Okay, so on top, it's always positive. This is positive. Okay, that is going to be 10, negative 1. It's going to be positive because even though it's negative, since it's squared, it's going to result to a positive number. Therefore, this is going to be positive. So on this part, it's going to be positive. So from the interval of 1 to infinity, we're going to get 10 again, okay? 10. So on the top is still positive. That is 10 minus 1 is going to be still positive. So the result will be positive. Now look at this one. This is kind of very interesting because it says that the rational function should be lesser or equal to 0, but we cannot see any negative in here. Therefore, we can say that there is never, okay, lesser or equal to 0. Okay, so in mathematical terms, you can actually see this one. So it's actually the null set. No solution. Okay, so let's go for the last one. Here's the instruction. Example 7, the graph of the rational function f is shown in the figure above. Use the graph to solve the following inequalities. Okay, first, I suggest that we're going to highlight those that are above the x-axis and also this part. If you're going to look at this part, that is actually above the x-axis. And I'm going to put the purple color below the x-axis for us to easily recognize which one is above or below the x-axis. Okay, so it says here that f of x is less than or equal to 0. Okay, so let's see, less than equal to 0. So which part? That's going to give you from here. Yeah, and then it will stop on this part. So that means that's going to be from the interval of negative 3 to negative 1. And 1 is a 0. Also, with the union of, on this part again, if you can see this part, okay, that's going to be from 2. 2 is a 0, so we use brackets, and then 3. Okay, so this is how you're going to answer it. Or we can also do it in another way of notation. That's going to be negative 3 less than x less than equal to negative 1. And the value of x is going to be 2 and 3. Okay, letter B. Let's look at letter B in here. B says that f of x should be greater than 0. So we know that anything that is above the x-axis is going to be greater than 0. And there are 3 parts that I can see in here. Okay, so if you're going to look at that part, this one, this part, this small part, and this part. Okay, so let's do that. So the first one is going to be starting from here. That's going to be negative infinity to the asymptote, which is negative 3. Okay, negative 3. And then with the union of here, the root from negative 1 to 2. Okay, this is going to give you negative 1 and then 2. And with the union of this one, this part, that's coming from the asymptote, which is 3 to infinity. Okay, so that's how you're going to answer it. Okay, letter C. It says that the f of x is greater or equal to 1. Okay, letter C. F of x is greater or equal to 1. So let's see. If you're going to notice something in here, greater than 1, it should be above 1. And what do you see in here? 1 is actually a horizontal asymptote. Okay, this is a horizontal asymptote. Therefore, to answer this question, it means to say that the interval is starting from this part in here until here. Okay, but we can write it this way: from negative infinity to the asymptote here, this is going to be negative 3, and the union of, okay, starting from this asymptote again, which is going to be 3 to infinity. Okay, so this is the answer to these questions. Okay, so this is all for topic 1.8 for AP Pre-Calculus on rational functions and zeros. If you find this video helpful, share, like, and subscribe. Thank you very much.